Okay, so you guys were having a little bit of trouble with function transformations, which is completely understandable. So my family has kindly volunteered to help me demonstrate these transformations. So the first one, the one that I saw the most issues with, was f of negative x. And what this is going to do is reflect our graph across the y-axis. So if I have a point 1, 1, and then I have f of negative x, that's going to reflect it to negative 1, 1. Okay, so let's compare that to negative f of x, which is behind our point right now. But so, whereas f of negative x reflect across the y-axis, negative f of x is going to reflect across the x-axis. So it's going to take our point 1, 1 and reflect it to the point 1, negative 1. So now the question becomes, what happens if we have both of these reflections occurring? So we have negative f of negative x. And the answer is we reflect across both axes, which ends up acting as a reflection across the origin. So 1, 1 becomes negative 1, negative 1. Okay, let's talk about horizontal translations. So written down I have f of x minus h. Remember, when we're talking horizontal, we're going to go the opposite of what you think. So since I'm looking at x minus h, I'm going to move to the right or towards the positive side. And we've decided that h is going to be 2. So we're going to move from the point negative 1, 1 to the point 1, 1. Oh, 1, 1. Our actress is obviously not a professional. She missed her point. But so you can see that we simply shifted horizontally those 2 units. On the other hand, if we are taking f of x plus h, then we're going to move towards the negative side of our graph, which is going to be towards our left. So again, our h is 2, and our point translates. When we start talking about vertical translations, now we're talking about f of x, in this case plus k, which means we're translating up. We've decided that our k is going to be 3. So our point is going to go from 1, negative 1 to 1, 2. He shifted up 3 units. Now if we're subtracting k, so now we have f of x minus k, we're going to do the opposite. Our graph, or our point, is going to shift towards the negative y's, and our k is still 3, so we're going to go from the point negative 1, 2 to the point negative 1, negative 1. Now if we talk about a vertical stretch, so this is a f of x, that's going to make our graph taller when a is greater than 1. So in this case, we're going to make our a equal to 2, and what's going to happen is you can see the yellow, which was our original line, and then you can see that those points, 1, 1 and negative 1, 1, have now stretched up, which makes our graph appear thinner, but we really want to say that it's now taller because we moved it vertically. Now if we talk about horizontal translations, so in this case f of bx, and we're going to make b equal to the same 2, and we're going to work with the same absolute value graph. So it looks like we're doing the same thing. When we put a 2 in for b, those 2 points move exactly like they did before. But now if we're describing this, we're going to say that the graph got thinner instead of saying that it got taller. Okay, because now we're going to talk about the horizontal transformation instead of the vertical. Hopefully these demonstrations helped you. If not, you know how to get a hold of me and ask some questions.